This is the data set that we are going to be using for the workshop on decision trees. It is stored in a file called diabetes.csv. So the data for this case study is the Pima Indian woman that's living in Phoenix, Arizona. The woman has been under continuous study since 1965 by the National Institute of Diabetes and Digestive and Kidney Diseases because of its high incidence rate of diabetes among the women. There are 768 instances or rows of data, and there are 10 features. So in the first column, we have here the serial number. This will be the same as the patient ID that will identify each unique patient. And then we have the pregnancies, the number of pregnancies that the woman has had in the past. And then the next is the glucose level, the blood plasma concentration. And then we have the blood pressure or the diastolic blood pressure. And then we have the next column, which is the skin thickness. This is the pinch test. And then we have the insulin level that is measured in the 2-hour periods. And then we have the body mass index of the patient. And we have the diabetes pedigree function. This is an indicator of how likely you are to get the disease because your parents or your relatives have the disease. And then we have also got the patient's age. And finally, the outcome is whether the patient has diabetes or doesn't have diabetes. So all these columns here, starting from column B all the way to column I, will be used as input variables to do a prediction on the outcome, which is the target variable. Next, we are going to import this data set into Orange Data Mining tool. This is the decision tree workshop using the Orange Data Mining tool. This workshop comes in 3 parts. In part 1, we are going to do data exploration. We are going to see what the data contains, whether we can derive some useful insights from the data. And then in part 2, we are going to train a decision tree model. And then in part 3, we are going to take the trained model and we will deploy it. All right. So here is the canvas of the Orange Data Mining tool. And we will be putting widgets onto this canvas and link them up. And then we will create a process or a workflow that will allow us to analyze the data as well as to build models. Okay, so let us get started with part 1, which is data exploration. So part 1, we are going to do 3 things. The first thing we are going to do is to import the data set. And after that, we are going to specify the different data types. If it's a numeric data, we want to specify them as numeric. If it is a categorical data, we want to specify them as categorical. And then in the third step, we will explore the data using some visual tools like feature statistics, data distribution, scatter plot, and correlations. Okay, so without further ado, let us import the data set. To do so, I would need a widget, and the widget is called the CSV file import. And because my original data set is in CSV file format, so I will need a widget called the CSV file import. All right, so I'm going to double click on the widget to open it up. And here is where I will select the file that has been downloaded, and it's the diabetes.csv file. So I'm going to look for the file, and here I found it, diabetes.csv, and I'll click open. And this is the data set that we have seen earlier when I was explaining to you the Excel sheet earlier. All right. So the next thing I want to do after I've imported the data set is to actually specify the different data types. Okay. So here we have the first column, and the first column is the serial number, which is equivalent to the patient ID. Now this has no information value, so we are not going to explore this data. So I'm going to mark it as ignore. And for the other columns, as you can see, they're all numeric. So I'm going to select column 2, 3, 4, 5, 6, 7, 8, and 9. All right. And I will set them as numeric variables. Okay. And the final column is actually the outcome or the target variable. And I will set this as categorical because 1 means the person is diabetic and 0 means the person is not diabetic. Okay. So here I have set up all the data types and I will click OK. And I will close this window as well. Now let us view this data in the table format. So I will link up a data table widget. All right. So this link over here shows that the data is flowing from the CSV file import into the data table widget. So I'll double click this, and as you can see, I have this table, which is really the same thing as our Excel sheet that we've seen earlier. Okay, so you can see patient number 1, 6 pregnancies, glucose level of 148, blood pressure of 72, skin thickness of 35, and so forth. All right, and the patient is actually diabetic because there's a 1 there in the outcome. Okay, now you can turn off the visualization or you can turn it on. This you can toggle it. All right, this visualization basically gives you a little bar there to indicate how much of the value is there. So the longer the bar, the higher the value. Okay. Now there is 766 68 instances, and there are 9 features. And the reason why we have 9 features is because we have eliminated one of them, and that is the serial number. But we also note that there is 0.7% missing data. All right. And there's no target variable. And the reason is because I haven't set it. So I want to show you another view of this table that could have more meaning for you. So to do so, I'm going to attach a select column widget, all right, and I will connect the select columns to the data table and remove this widget. All right, so this is the setup here. All right, so the data is flowing from CSV file import into selecting columns into data table. All right, so under select columns, as you can see, um, there is a target variable here. Actually, Orange has kind of anticipated what I'm going to do with the data. All right, so it has decided for me that outcome is the target variable, even though I didn't quite say it, but it has actually assumed that. And these are the features that are variable or features that are going to be displayed, all right, in the table. Okay, so if I'm going to close this one now, and I will now look at my data table, I should have a different view now. So as you can see, the view has changed and we have a lot of colors here now. Okay, so Orange has done something for me here by labeling in color every patient. So patient number 1, for example, has a red label for all the different features. And the reason being that patient number 1 is diabetic. So diabetic is labeled as red and non-diabetic is labeled as blue. Okay. Now, if I want to toggle this and to show the gray colors, I can just remove the check boxes here. And as you can see, it is no longer showing me whether the patient is diabetic or non-diabetic. But if I really wanted to appreciate what the data contains, I can actually click on it and have it shown this way. Okay. Now, over here, you can also do a couple of things. The first thing I want to do is to be able to do this. I want to sort my data set. All right. If you click on the feature label itself, you are actually sorting it. In this case, I am sorting it from small to large. Okay. And if I click it again, it will toggle. So it is now sorted in descending order. Okay. Now this allows me to explore my data as well. So you can see that the higher the glucose values, it appears that there are more red values within the column here, which means that there's some association between diabetic patients and their glucose level. Because if I click it again, I'm actually sorting it in reverse order, so in ascending order. So you can see that there are no red rows over here or bars over here, which means that the low glucose values are associated with non-diabetic. All right. So you can actually do the same thing as well for the rest of the columns. You can click them and you can sort them. So for example, BMI, I can click it and I'm sorting it in ascending order. All right. And if I click it again, I'm sorting it in ascending order. So you can see that in the ascending order, again, the BMI, the higher the BMI, seems to be associated with people who are diabetic. Okay. So if you were a physician, all right, for example, if you're an endocrinologist, that's the doctor that actually specializes in diabetes, they will probably have a lot more to explore in this data set here. It will be more interesting to them because they understand the domain well. They know things about skin thickness, blood pressure, BMI, and how it affects the diabetic disease. Okay, so I'm going to leave this for now. I'm just going to click here and stop looking at that data set from there. Now, the next thing I want to do is to explore the data using feature statistics. All right, so I'm going to link up a widget feature statistics, which is found here. Okay, and I'm going to double click on it. And here it shows me in bar charts, all right, or distribution, um, all the different features. Okay, again, the label is by outcome, okay, which you can again toggle. So look at the insulin distribution here. One can see straight away that the distribution is a skewed distribution. It is a positively skewed distribution. Okay, it has a mean value of 79 for insulin level, and it has a median of 30, and it has a dispersion of 1.44. All right. This dispersion value, it is not the same as the standard deviation that you are probably more used to. This is actually referring to the coefficient of variation, the COV. All right. So it's a slightly different interpretation. The COV is actually the standard deviation divided by the mean. So it is the proportion of the standard deviation of the mean. The higher, meaning that the standard deviation is very large. All right. Very often you would want the dispersion to be small as possible. Okay. So in this case, you can see that the dispersion is 144% actually. So we can see that this is a highly skewed data. All right. And the minimum value is 0 for insulin, and the maximum value is 846. Now, this maximum value is pretty high, and therefore you should expect that there could be outliers in the data set. All right. Now, if you look at the glucose distribution, which is the second row, you can tell that there is some insight here that we can learn from, and that is as the glucose levels goes higher, the proportion of red is larger, okay, compared to the blue. So if you were to take this bar over here, the third bar from the left, you can see that the proportion of red is very small compared to the blue. So what it means is that the red are those people who are diabetic, all right? And as you move further up the glucose level, more and more people proportionately are diabetic compared to non-diabetic. So there seems to be some kind of a relationship here between glucose level and diabetes. Okay. Now, if you look at blood pressure, you can see that it is a fairly normal distribution. They hardly seem to have any kind of outliers or um, skewness here. In fact, if you look at the mean and the median, they're almost the same number. So I would say that this is probably a very normally distributed data. And not only that, the distribution of the blood pressure amongst the diabetic, which is the red part of the chart, versus the blue part of the chart is pretty much the same. All right, so there is no specific indication that blood pressure and diabetes is related in any kind of unique way. All right, normal distribution. So over here, you can again, like I said, do a lot of data exploration, and you'll probably find this interesting if you're a physician or an endocrinologist. Okay, so I'm just going to close here and move on to the next step. Next, I want to join a distribution widget to the file import, double click, and here we have the distribution for the different features. What is showing now is the distribution for pregnancies. Okay, now the distribution actually shows you the histogram. In this case, the histogram has been defaulted to an interval of 10. So you can see that the first bar represents 0 to 10 pregnancies, while the second bar represents 10 to 20 pregnancies. Now I'm going to change that by using the slider that says bin width over here. All right. So I'm going to slide it down and I will create a interval of 1. So here we have changed the histogram to show intervals of 1. So the first bar would represent 1 pregnancy, the second bar would represent 2 pregnancies, the third bar 3, and so forth. And you can see that we also have a curve that has been superimposed, or we call it fitted over the data set. And this is actually a normal distribution. So it shows you what your data set should look like if it were normally distributed, given by 2 parameters. One is the mean, which is mu, and the other one is the standard deviation, which is sigma. Based on these 2 parameters, a normal distribution curve can be created. Okay, so here you can observe that the bars do not quite follow the curvature of the curve. So it deviates from a normal distribution. Okay, let's look at another one, which is blood pressure. Okay, so for blood pressure, you can see that the bars follow quite closely the shape of the curve. So you can conclude here that the blood pressure is actually a little bit more normally distributed compared to pregnancies. And I think we've also seen the same thing in the previous feature statistics widget. Okay. Now, another thing I can do here is to split the data, the visualization by outcome. Okay. So here it is showing me 2 different distributions. The first distribution is the blue, which is non-diabetic, and the second one is red, which is diabetic. All right. This is the distribution of blood pressure between diabetic and non-diabetic patients. As you can see clearly here, that the 2 curves are quite close together. There's only a slight to the left and to the right. Okay, but by and large, the shape is pretty much the same, and the bars are pretty much the same as well. Okay, so this is the distribution widget, and at the bottom here, you can see that there's a triangle, a yellow triangle, meaning there's a warning over here that tells you that there are some instances with missing values that are ignored. All right, so it is just a warning. It doesn't affect the way the curves are displayed. You can still interpret them meaningfully. Okay, so I'm going to close, and you can see that the triangle remains over there. All right. The next data exploration that we want to carry out is the scatter plot. So I will create a link, a connection to the scatter plot. Okay, and I'll open up the scatter plot, and here it is showing me the scatter between blood pressure and BMI. All right, so you can see that the plot shows that all the data points are pretty much in one location, right? So it appears that there isn't much of a relationship between blood pressure and BMI, looking from this scatter plot here. Now, I want to color this by outcome. So I'm going to select outcome. And here we can see with a little bit more insight, the distribution between the diabetic and the non-diabetic, okay, when we compare the blood pressure versus their BMI. Now, I will also want to draw your attention to say that there are outliers, as you can notice. There's one outlier way on top over there, all right, with a blood pressure of 110 and a BMI of 61, all right. And there's also probably another outlier over here, okay, and maybe over here as well as over here, okay. So you can appreciate that a scatter plot will reveal to you, number one, relationships. Number two, outliers if there are any. Okay. Now to make this more meaningful, I'm going to specify that I want a regression line, okay, to be plotted for me. So with the regression line, it also gives me the correlation coefficient R. Okay. So as you can see, the correlation coefficients are all 0.25, 0.29, 0.26. They are quite insignificant. This is because there probably isn't any kind of relationship between blood pressure and BMI. Okay. Now the correlation coefficient is also shown for diabetic in red, non-diabetic in blue, and the average, which is in black. Okay. So there's nothing interesting over here. And the next thing I want to look at may give me a little bit more information, and that is perhaps there could be a relationship, okay, between, say, pregnancies and age, right? Naturally, we think that, there should be some kind of a relationship. So I'm trying to see whether is there any relationship. So here I have plotted pregnancies versus age. You can see that the correlation coefficient is slightly stronger than the previous one, and it is for the diabetic, it is 0.44, non-diabetic 0.57, and the average is 0.54. So there's a little bit of a moderate relationship, positive correlation between pregnancies and age, all right, both for diabetic and non-diabetic. Okay, so I'm going to close this scatter plot now, and we will next look at correlations. Before I add the correlation widget, I just want to do some housekeeping. I want to rearrange this so that there's enough room. Okay, so let's now join a correlation widget to the dataset. Okay, and I'm going to double click it. And here, Orange has actually sorted out the correlations for me. And these are showing all the different combinations of correlations. Okay, as you can see, the highest correlation in the entire dataset is between age and pregnancies, and it has a correlation of 0.54. Okay, followed by insulin and skin thickness and so forth. And if you were to scroll down, you can see that there is hardly any relationship between blood pressure and pedigree function. Okay, so this will give you a sense of the kind of data that you are working with overall. I'm just going to close this window. Okay, so we've actually covered quite a fair bit of data exploration. You can explore the data a lot more on your own, but this is what we have here, all the different ways of exploring your data. Okay, and we are done with data exploration. In the next part, we are going to build the decision tree model. That will be part two of the workshop.